Okay, I got shut off of the battery. It went dead. Alright, now, as I was explaining this thing, I haven't looked at the video yet, so I don't know where we lost. I think I was here explaining about a sample cap. I used this over to a receiver to actually listen to see if I could get signal through these the first RF amp. This is the antenna coil over here, and this is the coil on the plate of the 6BH6 is what I'm using on this one. And this one here was just, I had a little coax running to the input of a receiver so I could hear if it was picking up the signal. This coil here, that's the first IF can out of a CB receiver. It's out of the Johnson Messenger 2 is where I've took that first IF coil out of. This circuit has the 6BE6 in it, mixer, and part of that tube is going to be the local oscillator. That circuit I just showed you earlier is how I have this all hooked up. And this little thing runs on 28 volts. That's the fun part. 28 volts, and I've got everything hooked up right now since I have two tubes. The first RF amp and the BFO are both 6BH6s. Now there's something I want to talk about just real quick. Where did here they are. Okay, when you're choosing tubes and you're going to select a filament voltage, let's say you're going to want to do 12 volts, there's something you're going to want to pay attention to. I don't know if you can see that, but in the specification sheet it shows the voltage that the filament voltage runs at, and right there with it it's going to show the current. On here, this one uses 0.15 amps, so it's 150 mils of current. And if you're going to hook two in series, if you're going to hook two of these so the filaments are hooked in series, you're going to want that current to be the same on both tubes. Just thought I might point that out, because some of them are as much as 400 mils per tube, and others are like 300. So both of these, particular the BH6 and the BJ6, both of these tubes can run at 0.15 milliamp, actually 150 mils. So 150 milliamps of filament current. And you can hook those two together in series, and you can hook 12 volts to them. So one tube, it would start out, you'd ground one pin, the other pin would go to the filament pin of the other tube, and the other filament pin of that tube would then be where you'd hook your 12 volts. So they're in series. Okay, that done. All right. Here's what I was talking about. These capacitors here, they're kind of hard to use. You actually have to kind of either use a screwdriver, or I think I've even got a, I don't see it right now, but you could use a nut driver, because they have a hex. This collar right around here is a hex, it's a 1/4 inch hex, and you have to mount them with 2 screws. So it's more convenient if you can find these that have a threaded collar. Now actually, in all 100% perfect world, you would want that capacitor to look like this. This is 100% perfect, ideal. It's the perfect capacitor. You got 2 capacitors. They're separated. They're on separate ceramic standoffs. So there's 2 separate capacitors with a common ground. And that's what you have, is the rotor on these is grounded, and the outside cage, the fins, are your live part of that capacitor. But you'd have to turn both of them, and you diddle with one and then go turn the other. This, both capacitors turn at the same, so this is what you're looking for. And you would want to find one in the neighborhood of 100 picofarad at least. 100, if not 150 puff. Then you would have just, you would mount the coils underneath. This would go below, or rather above the chassis, and you just run, you'd set the tube maybe on one side, and so the antenna coil could be closest to one, and the plate coil a little farther away, and you just run it, a wire from here straight down to the coil. You wouldn't want to run those leads too far. What that keeps away from is the tube oscillating. If you had leads that were too far or too long, and here what I've done is I've separated them with a little copper wall, so that I put one of them on each side of the wall, and that stops any tendency for the things to break into oscillation, because they're still a pretty high gain tube, even though they're on 28 volts. Okay, so that's pretty much it for this trip. I'm going to test this out and get it tuned up and see if I can't get WWV on it, and then I'll actually know that this could be need 2 or 3 more stages on here, and you'd have a complete shortwave radio. Just a matter of changing your the two coils. All right. If you'd like any of the schematics, shoot me an email. They're JPEG form. They're small. Most of them are around 80 to 130K. I download them as a PDF, and I use this thing online called PDF to image. If this is the first video you've watched, I've talked about it in the videos before, but I download it first as a PDF, and I go online to pdftoimage.com. Stay away from any of the funny little download this now, or your low driver, driver refresh. Don't pay attention to that stuff. They're all little gitches. Don't even try to close them. Just ignore them. The one thing you're looking for is the one that says, yes, across the top of the page, it'll say PDF to image. You click that, it'll say upload file. It opens your box to where you go through your folder. You select the image you want, click on it. Over on the left part of the screen, about in the middle, it'll say downloading, or uploading rather, and then when it'll give a percentage, and then when it's done it'll say converting, and then when it's done converting it'll say download file. That's the one you click on. There is another thing that says download all or something, but again, I think that's one of them trick things, so don't pay any attention to that. But if you want any of those JPEGs that I've drawn, any information on that stuff, just let me know. I'd be happy to shoot you back an email with whatever JPEGs you want. So, thank you for watching, and if you want to know about any other upcoming video, please subscribe and hit the notification bell, and even looking for a like if you think this video has helped you out and given you any information, because I'd like to get this to where more people can find it on YouTube. I see a lot of sites that show what they've built, but they don't seem to give a lot of information, and I'm going to do my best to give whatever information is needed so that you can actually follow along and build a circuit. I'm I even have no problem helping on a one-to-one. If you get a circuit going and something don't work, maybe send me a schematic, and I can work through it, test it, and then maybe find you where it's a point on it, maybe it's drawn wrong or something, or if there's a problem, I can let you know about it. I'd be happy to work with anybody on a one-to-one basis. So thank you, and we'll see you on the next video.